In front of you is a bountiful selection of horns. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26? I thought it was 24. Wait a second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I don't know what was going on there. So yeah, there's 24 horns. This has taken me a surprisingly long time to actually make all of these. They're all 3D printed because I bought a bunch of these Dixie horns. They're really out of tune and they're not actually that loud. And they're really actually quite hard to modify. So what I decided to do was make a shape that reminisced a horn on Onshape, which is a CAD program. After a bit of fine tuning and fiddling and many shapes, where are they all? I've got a bunch of finished, non-finished ones. Oh yeah. After many a different shapes of fiffing around, trying different curves and different shapes of horns, I came across one that was kind of reasonable. One that had a little bit of rasp, but was also very noisy. Basically what I did was I printed it out and then extended the design a little bit and basically guesstimated my way all from F6 all the way up to F sharp 4? Yeah, G4. So basically I've got 2 octaves of the chromatic scale of 3D printed horns. The larger ones I had to split the design in half so I could glue them together because they were too big for the 3D printer, of course. The link to the Onshape program where you can program the lengths of them are below, and there's also a zip file of all of these, but to be honest, they're probably not much use, but they might be. I don't know. I've basically designed these to work inside the back of these Dixie horn ones. So basically what we do is we modify this, we remove the horn that I thought was going to be modifiable by itself, but it wasn't, and then plonk these in. And we get a bountiful array. I need to put my earplugs in. I need to plug this compressor on really quick. Let's get some sound in here. Oh! And what you do is you basically get a couple of these, like this note. This is D sharp 6. Oh my God, they're really loud. It took me a while to get it this loud, but I can't listen to it without earplugs in. It's horrendous. And then we've got F5. Oh, what have we got here? A4. There we go. So yeah, it's all going up. I've designed them in such a way that they're slightly adjustable. I can fine tune them. For instance, this one right here, G sharp 4, we've got these couplers on top. So basically that wasn't the right note. So that's now the right note. And these are all adjustables by size. So the plan is to get the note pretty much as close as we can do, glue it all together and glue it in place to the resonant horn making thingamajig. The reed? I think it's a reed. I should probably do all the research before I make this machine. But enough of that malarkey, we should probably make an instrument out of these things. I have already got myself a bunch of valve solenoids, much like they were in the flamethrower organ. And what else did I use these in? Flamethrowing Henry Hoover and the other flamethrower organ. All of that stuff. So we're going to use these valves on a nice big copper manifold. And we're going to basically try and turn this into a really elaborate horn, I suppose, like those truck horns that are really elaborate. Maybe put a keyboard on it. Now, if you can tell, this thing is going to be pretty big. So I'm going to make it in its own enclosure so we can put it onto whatever vehicle we need to make sure that we need to know that our presence is present and stuff. So just earlier today, I got out the Rapidor Manchester and I went to town and chopped up a bunch of box section. Many a bits of box section. And the first thing I think we're going to do today is actually make the enclosure to put this all in. I've got an idea in my head of what I want it to look like. I've cut this stuff thinking it's going to look like that. And the only way we're going to find out if those two things indeed do match up is actually just plopping it together. So I'm going to clear the table and we're going to make the enclosure. Oh no. I should have thought this through. I didn't think this through. Oh, what an idiot.
The first thing we're going to do is put all the box section into these cheapo 90-degree clamps I got a while back. These things keep on biting me by the fact that they're a little bit too long, so I figured, screw it, let's chop the ends off and actually make them a bit more useful. I don't know why those handles are so large, so there we go. In this project, you'll see a rare instance of me actually using a tape measure. That's right, a tape measure. Yeah, it turns out there's quite a lot of bits of box section in this project, so I've got to make sure it's nice and square or it's going to be as wonky as a donkey. So this is me welding together the front of it. It's got 2 shelves, so we can actually fit all of the horns row by row. And now we've got that, we're going to put the back panel together. This is a lot simpler because it's just 4 bars on the back. And once we've got that plonked together, we crack out the 90-degree clamps again and plonk the front and the back together on some crossbars. Weld the bottom ones in first once we know they're bang on 90 degrees. Well, as bang on as the eyes permit. Anyway, once we marry the front and the back together at the bottom, we're going to be able to plonk the tops on so we can complete it as a big cube and finish off the shelves from the side so we can actually plonk in the horns. It is very overbuilt, but I quite like overbuilt. It's nice and fun. This is way heavier than it needs to be, but it's cool. It's a bit of fun. Anyway, I decided to change the plan a little bit last minute on this, and I decided to have them all at the same line at the front. So we're actually going to be putting a diagonal bit of metal in so we can actually bolt them all in staggered so they actually meet the front of it equidistantly. So this was a bit of an eyeball job, and I went staggered, so I went one going that way, one going the other way, and one going that way. And once that is done, all of the bits of metal are plonked together, and we can paint it with a nice coat of hammered black.
The next thing we need to make is something that is going to connect all of the solenoids that are going to turn on all of the horns to the compressed air supply that is coming from the 2, yes, 2 because it's better than 1, probably because it looks cool, the 2 compressed gas pump thingamajiggies, the air compressors, that's what it's called. So what I'm going to use is off-the-shelf plumbing supplies. We've got this wiggly worm, so it's basically 22mm plumbing T-pieces, and then we've got 22mm pipe. There's about 8mm chunks, and then we've got a bit going off that's 15mm, and that goes off to the solenoid. And then we're just going to basically solder a load of these together, 24 in total, to be able to, here's one I made earlier, ooh, it's a little bit on the hot side, to be able to make a snazzy looking manifold. I think it's going to look quite cool. I've got all of the bits cut out, so we just need to solder it all together. So let's get cracking.
This is definitely the biggest manifold of its type I've had to make in this instance, so it was a little bit of trial and error. I did it the same way as I usually do, kind of heating it up and then using some steel wheel to give it a clean, but it just kept on going. It just kept on getting longer and longer. I just figured if I used a ruler to make sure I was going straight and just kept on going, it was going to work out for the best, and it turns out it was all right. I had to rejig it a couple of times because it did go off straight a few times, but after a while I was able to go onto the sides to make the top and the bottom part so we could be able to plonk 3 of them together, and actually amazingly enough all lined up. And the worst thing is if it doesn't quite line up, you just have to heat up one of the joints again and start. That's the great thing about soldering, is you just heat up and then after a while it looks like this, and this is bang on airtight. That's pretty snazzy. Anyway, we used this, which is a 15mm to, I think it was 1/4 inch BSP fitting, and this means we can fit the valve solenoids onto there. Actually, those might be 1/2 inch BSP fittings. You can get these valve solenoids in a load of different configurations. I think I went for 1/2 inch 12 volts, but you can get 5 volt ones and you can get 24 volt ones. 12 volt seems to work well because it works with the car battery and the power kind of setup that we're going to be doing, because remember, this is automotive. There's a little bit of automotive technology thinking in there, like using relays in the electronic design. Anyway, after plonking them all in, I went for these tiny little push fits on the other side to aid for ease of fitting to the car horns.
Plumbing it. The manifold is now done. We can kind of wiggle it in here. Scratching all of the metal work along the way. Oh no, doesn't fit. Come on.
That's right, even more off-the-shelf plumbing fittings to fit it onto the pre-threaded holes that are put into the steel. And now we're going to put the cheapo air compressors onto the back. I went for 2 purely because 2 looks cooler than 1, and I figured it'll pump up quicker. Whether this is enough reservoir for air, we shall yet to find out. And this will be the project enclosure for the electronics, which we are going to put an Arduino Mega in for ease of troubleshooting later on. And also, instead of going solid state like in the organs, I decided to use relays because they will be easier to troubleshoot on the road if I do actually use this in a car, which is, yeah, I know. Yeah, it seems practical, right? Anyway, we use these nice rubber kind of standoffs to be able to stop some of the sound going into the cages. It works quite well. We plonk those in and wire up the hoses into some more push fits on the back of the reservoir, and they look pretty snazzy. And we've got this back off plate that's got some screw terminals to ease kind of troubleshooting later on. I also soldered a MIDI input circuit for Arduino using an opto isolator right there, and then slowly but surely soldered all of the wires from the relay board over to the Arduino Mega, literally one relay per Arduino pin, and then we're going to be using the organ code from Jones Organ Project to literally be able to turn the relays on and off via the Arduino via MIDI. If you search up Jones Organ, I talk about this code all the time. I use it quite a lot. It's very usable and it's publicly available over on my website. Anyway, I've 3D printed these mounts because I decided on a different spot to be able to put that enclosure. So we're going to be having it facing up now. I don't know why I did that. I think, oh yeah, it was so I was able to take off the clear cover easier and it looks a bit cooler. A lot of my decisions are down to cooler looking kind of decision choices. Anyway, now we're going to wire in all of the wires going from the solenoids through those glands into the relays bit by bit, one by one. I went for some multi-core cabling, which I meant I needed to put some solder on the ends of them to kind of give them a bit more kind of strength to get them into the screw terminals of the relay boards. Anyway, we're going to put some cable ties in there to clean it up and start fitting the horns. So I threaded a load of M4 holes straight down these diagonal pieces to be able to fit some 3D printed parts that we can plonk the horn backs to them. So this is some heat inserts that we're going to be able to plonk the off-the-shelf bits of car horn that you buy literally from eBay and stuff. So we're going to plonk these on before we fit the actual horns. So little bit by bit with some Allen key M4 bolts. This was a little tedious to say the least, because there was a load of these and they all needed lining up bang on, and lo and behold I didn't line them up very well, so there was a lot of intervention there. Anyway, you can get an idea of the weight right there. It's a little bit of a lump this now. Anyway, these are the modified Dixie horns, so they're basically the rear sound diaphragms, but I chopped out the front horns, drilled a holes to be able to fit the custom 3D printed ones. I started with the highest pitch row just to see what they sounded like. If you can't tell already, I've tuned them to a lower fundamental so I can run them at a higher pressure to make them even louder. And I've got to say, it is very loud. It's very uncomfortably loud. It's about 130 decibels. And yeah, that's not a very pleasant thing to listen to. In fact, I can't listen to them without earplugs at all. Anyway, after fitting the rest of the 3D printed parts, we're able to put in the rest of the horns. So slowly but surely, we're putting all of the extra cut and modified sound diaphragms from the original horns that we're actually now running at about 3 times the air pressure to be able to make them extra noisy in the pursuit of why not.
Behind me right here is a car horn I've been working on and off for the last few months. And I've sort of made it lethal, and I didn't realise until just doing some tests right now. So this is a decimeter. It will be backwards. I put it on hold at 130 decibels, which is I think the max for this, and it's gone past the decimeter. So I'm just going to press play. I'm going to rickroll you, and I'll show you how loud it just blown a bunch of the pipes off. I need to work on it, but it's gone past 130 dB, that'll literally break your ears if you didn't have earplugs in. If I was this close and I had that playing, my ears wouldn't work. So maybe this isn't going to work as a car horn.
So that is where it's up to in part one. As you can see, it's a bit rough around the edges. It's not quite finished. I know there's some OCDers out there going, oh no, all the horns are wonky. Yeah, I know. That's something I'll be solving in the next part. There's a few other problems, like the hoses keep on popping out from the horns. I'll solve that. And yeah, it needs to be made weather tight. There's a lot of things that need to be done, but let's appreciate it now for its ruggedness, its beauty, and its sheer volume. The next thing I'm going to do is give it a quick tune, and let's see what it sounds like when we play a few songs through it, shall we? Woo. But let's give it a quick tune first. We can do this by moving the horns backwards and forwards inside the diaphragms, because I haven't glued it in place yet. The plan is to glue it in place once they're fully tuned. That is a problem for the next video, mind.
Right, so time for some Patreon copyright-free requests. Here's for Michael Rugland, Horror of the Mountain King. Let's take it away. Just got the earplugs in, don't worry. So there we go, this is part one of the Deafenator. That was a good Instagram comment on one of the videos. I don't know what to call it. What should we call this? Deafenator? I quite like that. So in the next video, we're going to make it car horn friendly, which includes adding some front mounts to be able to make sure that they're all lined up, because right now they're all wiggling all over the place. And that will also add a bit of stability to them because they're also bouncing all over the place, which means we can put it onto a car. We're also going to put a windscreen on it, which will kind of muffle it up a bit because it is 130 decibels, which is rather loud. We're also going to put a bit of plexiglasses on the side. I just hit my head on that. We're going to make it weather tight, basically, so we can pop it onto the roof, and we're going to pop it onto the roof of, yes, the big Bogie. The eagle eyes amongst you might have noticed this tube coming off it. Yeah, sadly, the compressors aren't really up to much. They're pretty rubbish. In fact, they're an absolute waste of money. Would not recommend those cheapo mini compressors one bit. I'm running it off the main compressor, so that's another problem that I've got to solve. I'm just going to have to put a bigger compressor into the boot of the big Bogie, and then this onto the roof of the big Bogie. Yeah, so that'll be in the next video with mounts and just improving the tuning and just fixing a couple of the dodgy notes. That's the thing with making musical instruments like this. It's like, it's not like they're hard, it's the same as the organs. It's not like they're hard, it's just the same thing over and over again, and keeping it constant is a whole thing. The tuning is a whole faff. There's a couple of these that aren't quite sounding right. I think that I need to work on the sound reeds, the sound diaphragms, or whatever they're called. Anyway, that's it for now. I've got another really loud instrument that I'm starting to work through making now, and if you want to see what that's going on about and stuff, go and check over on Patreon, because I've actually been doing build logs on this machine over on Patreon for the last 3 months maybe now. This has taken literally 3 months, so yeah. Anyway, I'll see you after Eurovision, and I'll be back onto this and back onto the big, loud instrument that I'm talking about. Have a guess what you think it is. It's going on the roof of the museum. That might go on the roof of the museum as well. I'm not gonna be very popular at that point. Anyway, if you like what you see, don't forget to subscribe, and remember, don't be scared to try it. Toodaloo.